About 6 months ago, I started noticing something in my Upwork proposals. I would submit a detailed proposal for AI automation contract, LangGraph, FastAPI, clean architecture, production patterns, and I would lose some with fraction of my experience. The difference was one line on their profile. N8n. Not better engineering, not more experience, just a tool I had to learn. So I put some time into learning N8n properly. Not the build a Zapier style workflow in 5 minutes YouTube tutorial. The engineering version, what is actually doing, how does it compare with writing Python, when does it win, when does Python win, and how do I decide between them on a client project? This episode is that assessment. No demos today. We are doing architecture and honest engineering trade-offs. The demos start in episode 2 when we build an actual persistent memory agent. But if you start there without understanding this, you will be clicking notes without knowing why. This is the episode 1 of the n8n AI agent engineering. Let us get into it. Let me start by clearing up what n8n actually is, because there is a significant gap between its reputation and its reality in version 2.0. If you have heard 8 and 8n before, your mental model is probably something like open source Zapier, visual drag and drop workflows, connect your Gmail to your Notion. Non-technical teams love it. That was version 1.x. And it was accurate. n8n 2.0, released in January 2026, is different product. The headline feature is 70 native LangChain nodes, not bolted on, not a thin wrapper, but LangChain exposed as a first-class visual node system. Agent nodes, memory nodes, vector store nodes, language model nodes, tool nodes, the full LangChain taxonomy, all wired together in the canvas with typed connections. What does typed connection mean, by the way? It means the UI works, the UI knows that a vector store output cannot connect where a language model is expected. You cannot compose nodes incorrectly. The system prevents it. Compare that to Python, where you write wrong type and get a runtime error 3 layers deep in async call. The job specs that are killing my proposal are not asking for an n8n, the Zapier clone. They are asking for n8n, the AI agent orchestration platform. Those are different things, and they require different knowledge. The rest of this episode is about that second thing. So why would a senior engineer, someone who knows Python, knows LangGraph, and knows how to build this stuff properly, choose n8n over their own code? There are 3 arguments. Let me make each one. The first argument is transparency, and this is the one that surprised me most. When you build an agent in Python, you write your code, you run it, and if something goes wrong, you get a traceback. Or worse, you get a result that is just wrong in a way that is hard to explain. The agent called the wrong tool, the agent summarized a document it never read, the agent looped, and you are in a adding print statements and log handlers trying to reconstruct what the reasoning loop actually did. In n8 and 8n, every execution is first-class citizen. Every step in the workflow logs its input and output. Every LLM call shows you exact prompt went in and the exact completion that came out. Every tool invocation shows you what the agent decided to call, what parameters is passed, and what the tool returned. Timestamp, structured, and browsable. I want to be concrete about why this matters beyond just debugging. When you deliver an AI agent to client, whether it is a marketing automation pipeline or a customer support classifier, the first question they ask after it does something unexpected is, why did it do that? With Python, the honest answer is often, let me check the logs and get back to you. With n8n, you click the execution, open the step, and show them exact reasoning chain. That is different client experience. It also matters for regulated industries, healthcare, legal, finance. Anywhere there is an audit requirement, n8n gives you a structural audit log for every agent decision. Python gives you whatever logging you remember to build. The second argument is about how much faster you can give an AI agent access to external world. Here is farming I find useful. An AI agent is 2 things, a brain and a body. The brain is the language model doing the reasoning. The body is the set of integrations that let it actually do things. Read a Slack message, query a CRM, write a spreadsheet, send an email. In Python, you build both from scratch. The brain is your LangGraph state machine or your LangChain agent. The body is your all-out handlers and your SDK wrappers, maybe your rate limiting retry logic, your schema mapping code. A Slack integration alone, reading a message, parsing it, replying, is a few hours of work the first time you do it. Add Gmail, Airtable, Salesforce, and you have spent your whole week on plumbing before you have written a single line of agent logic. n8n ships with 1500 pre-built integration as nodes. Slack is a node. Gmail is a node. Airtable is a node. The authentication, the error handling, the retries already done. What takes hours in Python takes minutes in 8n. But the important part for the AI engineering angle is this. Through the workflow tool node, which we will get in a slide, everyone those 1.5k integrations can become a tool that AI agent can call. The entire integration library is in your agent's toolbox, out of the box, without writing the wrappers. The third argument is about where the data lives, and this one is often argument that closes the enterprise contracts. Zapier and Make are cloud only. Every workflow, every prompt, every piece of customer data you process passes through their servers. For a lot of use cases, this is fine. For a growing number of enterprise and compliance sensitive clients, it's a hard blocker. Healthcare clients cannot route patient data through a third-party SaaS. Legal firms cannot process privileged documents on an external infrastructure. European clients have GDPR obligations that make cloud-only automation difficult to justify to their legal system. n8n self-hosted runs in Docker on any VPS you control. Data processing stays in your infrastructure. The only outbound call is the AI model API, and even that you can route through a private endpoint or swap out for a local model via Olama. On a practical level, a Hackner VPS that is enough to run a production n8n instance with Postgres and Redis costs €6 for a month. Compare that Zapier's per task pricing, where a multi-step AI workflow running 1,000 times a month can cost hundreds of dollars. The economics flip entirely at scale when you self-host. I have closed at least 2 contracts in the last year where self-hosting was deciding factor. The client had a short list of candidates. I was the only one who could show them n8n running in Docker on their own infrastructure with their data never leaving it. Now I want to show you what is actually inside n8n 2.0, because the 70 LangChain nodes are the thing that makes all of this possible. Let me walk through the 5 categories of AI nodes in n8n 2.0 and what each one maps in your Python mental model. Agent nodes, 5 architectures: React, OpenAI functions, conversational, plan and execute, and a tool selection agent. These are entry points, the nodes that run reasoning loop. In Python terms, these are your LangGraph state graphs on your LangChain agent executors. In n8n, they are single node that you configure with a language model, a memory backend, a list of tools. Language model nodes, 14 providers or more, Cloud, GPT-4, Gemini, Mistral, and local models with Olama. The key thing here is the abstraction layer. You configure the cloud node, you build your workflow, and if a client wants to switch to ChatGPT-4, you change one node. The workflow does not change. The agent logic does not change. Just the model node. This is provider probability that takes real work to build in Python. Memory nodes, 9 backends, buffer for parallel sessions, Redis for persistence across restarts, Postgres for durable long-term memory, Motorhead for structural entity retention. We will use Redis in episode 2. The important point is that persistence is a node configuration, not code you have to write. Vector store nodes, 12 or more, Quadrant, Pinecone, Wavi8, Supabase PG Vector, Redis Vector. We will connect the Quadrant collection from the hybrid search series in the episode 3. That episode is a direct bridge between the 2 series, by the way. Tool and utility nodes, 30 or more, web search, text splitting, embedding generation, output parsing, document loading. These are utility layer that makes the other nodes useful. The slide highlighting is typed connections. The system knows what type each output port is, what type each input port expects. You cannot wire a vector store to a language model store. This prevents a whole category of composition errors that are easy to make in Python. The node I want to spend the most time on is one that is specific to n8n, and it is the reason I think n8n AI story is fundamentally stronger than Zapier's, even though Zapier has more integration. In LangChain and LangGraph, you define agent tools as Python functions. You write the function, you decorate it, you describe what it does, and the agent learns when called. That works and it is powerful. But the function is the limit. If you want a tool to call an external API, you write the client. If you want it to query a database, you write the connector. If you want it to send a Slack message, you write the Slack integration. n8n has a node called the workflow tool node. It does one thing. It takes any n8n sub workflow and exposes it as a callable tool to an AI agent. You give it a name, you give it a description, you define the input schema. The agent sees it exactly, it sees a Python defined tool. But behind it, it is a full n8n workflow with access to every one of the 1.5k integration nodes. So instead of writing a Slack integration in Python and wrapping it as a LangChain tool, you build a 5-node n8n workflow that reads Slack, processes, and replies. Then you wrap it in a workflow tool node and hand it to the agent. The agent can now use Slack and Gmail and Airtable and Salesforce and whatever else you can build in n8n, which is anything that has integration node. This is what I mean when I say integration velocity compounds at the agent layer. You are not just getting pre-built integrations for your own workflows. You are getting them as agent tools. The entire library becomes your agent's capability set. In episode 2, we built exactly 3 of these: a web search tool, a CRM lookup tool, and an email drafting tool, and wire them into a persistent memory Slack agent. You will see how quickly each one comes together. I want to be honest about the other side of this before we do the comparison table, because no tool is the right answer for everything. n8n is not a Python replacement. I'm not here to tell you throw away your LangGraph knowledge. There are 3 cases where Python wins, and you should know them before you make a tool decision on a client project. First, custom logic. n8n has code injection nodes. You can drop in a JavaScript or Python block anywhere in the workflow, but n8n is fundamentally a node-based orchestrator, not a code editor. If you are building something that requires custom data transforms, a proprietary parsing library, a complex regex pipeline, or multi-file Python modules that lives in a Python and gets called from n8n via HTTP request node or stays fully in Python. n8n is for orchestration around the code, not for replacing it. Performance critical inference. Every n8n node adds orchestration overhead. For most AI automation workflows triggered by a Slack message, for an email, by a schedule, maybe a webhook, that overhead is irrelevant. But if you are building a real-time inference endpoint that needs to handle 1,000 requests in a second, a Python plus FastAPI service with a direct API call is faster. n8n is not the right tool for that layer. LangGraph state machines, n8n agents patterns are generally powerful, but LangGraph conditional edges, shared state, and explicit graph topology give you more expressive control over complex multi-step reasoning loops. For the voice agent barging logic I built in the voice AI series before, with LangGraph managing turn-taking, interruption handling, and speculative execution, is not something I would try to replicate in n8n, because LangGraph was the right tool for that. The production answer is usually use n8n for orchestration and integration. Other side, use Python for logic that n8n cannot express cleanly. These compose naturally. n8n can call your FastAPI service via an HTTP node. Let me put all of this into one comparison table and then show you what we are building across 4 episodes. Here is the comparison I wish I had when I started evaluating n8n. 3 columns: n8n, Zapier, Python, and FastAPI. On an AI framework, n8n has native LangChain, 70 nodes, deep integration, Zapier bolted on AI actions, functionless but shallow. Python gives you full LangChain or LangGraph control. On agent memory, n8n has persistent memory via Redis or Postgres out of the box. Zapier agents are session only. They forgot between runs. Python gives you whatever backend you build. On reasoning visibility, we can tell n8n gives you the full execution load. Zapier is a black box. You see the result, not the reasoning. Python gives you whatever logging you implement. On cost at scale, n8n self-hosted is a fixed infrastructure code regardless of how many times your workflow runs. Zapier charges per task. Every action in a multi-step workflow is separate billable task. A 20-step AI workflow running 1,000 times a month on Zapier is thousands of dollars. The same workflow on self-hosted n8n is your server bill. Zapier's advantage is 8,000 integrations and zero ops. If you are a non-technical team and you need something running today, Zapier is the right answer. But for engineers, building AI agent for system for clients, the n8n trade-off is clearly better. Deeper AI capability, persistent memory, transparent reasoning, self-hosting, and economics that scale. Let me close that what this series actually builds, so you know where the next 3 episodes go. 4 episodes, 1 growing system. Episode 1, this one, gives you the mental model. We have not written a single node yet. That changes in episode 2. And if we come to episode 2, we will build a Slack bot with a persistent Redis memory agent. The agent has 3 tools wired up via the workflow tool node, a web search tool, a CRM lookup tool against Airtable base, and an email drafting tool with a human-in-the-loop approval gate. The agent drafts the email, you approve it before it sends. All importable as JSON into your own n8n instance. In episode 3, we take the Quadrant product collection from the hybrid search series and connect it to an n8n agent as a RAG tool. If you have watched those episodes, if you didn't watch it, please watch. The same Quadrant collection schema now accessible to an n8n agent without writing a single Python retrieval wrapper. If you have not watched those episodes, you can follow episode 3 independently, by the way. I will include a setup script also. Episode 4, we take everything self-hosted. Docker Compose with n8n, Postgres, Redis, and Caddy for SSL. We add a second specialist agent and wire up a multi-agent skill router. And I will walk through the 5-point governance checklist I use when delivering n8n systems to clients. Credential isolation, RBIC for agent users, audit log configuration, error handling patterns, and execution limits. Every episode publishes workflows, JSON exports to GitHub that you can import directly, by the way. That is the episode 1. 3 engineering arguments for n8n. Transparency, every reasoning step auditable, integration velocity, 1.5 key connectors as agent tools out of the box, and self-hosting, the client data sovereignty, and economics that scale. Then Python means complex custom logic, performance critical inference, LangGraph state machines. Use both. They compose cleanly. Episode 2, persistent memory Slack agent, Redis, 3 workflow tool node integrations, human-in-the-loop email drafting, and I will see you there. The GitHub repo link and my Upwork profile are in the description below. If you are building an AI automation system and want an engineer who has actually shipped this production, not just in a YouTube demo, please reach out. And don't forget to subscribe and like this video. See you.